Welcome to the lecture for section 9.1. In this chapter, we're going to be talking about geometry, and this is MGF 1106, Liberal Arts Math. So the objective for this lesson is that we're going to understand the basic properties of geometric objects, such as points, lines, and planes. We're going to work with the fundamental properties of angles, and then we're going to go ahead and solve problems involving the relationship among angles, arcs, and circles. So the first thing is we're going to go ahead and introduce points, lines, and planes. So a point is essentially that which has no part, and this is a definition by Euclid. And another definition is that a point is a location in space. Now a line has length but no breadth. So a line, we can essentially measure the length of line segments, if you will, but there's nothing else. We can't measure the width of a line. And then a plane has length and breadth only. We're going to see an image of a plane in the next slide. Now a point on a line divides the line into three parts. Now the point and the two half lines, and here we can see a line in diagram A, and then diagram B is a half line, and then diagram C is a ray, and a ray is a half line with an endpoint included. Now the last diagram, diagram D, is a piece of line joining 2 points, and including the points is called a line segment. So the next thing we're going to look at a parallel line. So parallel lines lie on the same plane and have no points in common. And that's the symbol for parallel lines. L1 is parallel to L2. And then intersecting lines lie on the same plane and have a single point in common. The next thing we're going to talk about are angles. So two angles having a common endpoint form an angle. So here we have the initial side, which is ray BA, and then we have the terminal side, which is ray BC. Now the vertex of this angle is point B, and the distance or the measurement between the initial side and the terminal side are measured in units called degrees, and then we use the symbol that represents the words degree. Now, we have different types of angles. So an angle whose measure is between 0 degrees and 90 degrees is called an acute angle, and a right angle has a measure of 90 degrees. There are two other types of angles. There's an obtuse angle that has a measure between 90 degrees and 180 degrees, and a straight angle that has a measure of 180 degrees. Now the next thing we're going to talk about are intersecting lines. So two intersecting lines form two pairs of angles called vertical angles. And here in the diagram we can see angle ABC and angle DBA. So those two angles are vertical angles, and vertical angles have equal measures. And that comes in handy later on when we talk about transversals. So a pair of angles is complementary if the sum of the measures is 90 degrees. Nothing new thus far. So here we can see that angle SQR and angle RQP are complementary angles. Now two angles having an angle sum of 180 degrees are supplementary angles. And here we can see that angle ZXY and angle WXY are supplementary angles. Now the next thing that we're going to talk about are perpendicular lines. Now there isn't an image of perpendicular lines, but two lines that intersect forming right angles are called perpendicular lines. And if you can imagine a cross, essentially, we can consider those to be perpendicular lines. Now if we intersect a pair of parallel lines with a third line called a transversal, we form 8 angles. And here we have the two parallel lines, a transversal that intersects both of them, and the 8 angles that are formed. And there are relationships for these 8 angles. And the first one is that angles 1 and 5 are what we call corresponding angles and have equal measure. Alternate interior angles, those angles 3 and 6, also have equal measure. Alternate exterior angles, in this case angles 1 and 8, again they have the same measure. And then interior angles on the same side of transversal, which will be angles 3 and 5, are actually supplementary angles. So here's an example. If lines L and M are parallel, find the measure of angle 9. So we're given some information here. We have angle A, which is 51 degrees, and angle B, which is 76 degrees. And we're going to use the information of the relationship of these 8 angles in order to solve this problem. So the first thing is that the measure of angle 8 is actually 76 degrees, and that's because they're corresponding angles. Now the next thing that we're going to do is we're going to use the information that angle A, angle 8 and angle 9 are actually form a straight angle. So the measure of angle 9 plus the measure of angle 8 plus the measure of angle A all have to equal to 180 degrees, and that's a straight angle. So now what we're going to do is go ahead and solve for the measure of angle 9, and we actually get that it's equal to 53 degrees. Now the next example, if lines L and M are parallel, find the measure of angle 2. So here we have angle 2. So the first information is that the measure of angle A, which is 51 degrees, plus the measure of angle 2 have to equal to 180 degrees, and that's because they're same side interior angles. So the next thing is we're just going to go ahead and solve for the measure of angle 2, and we get 129 degrees. So the next thing we're going to talk about are circles. Now, circle is a set of all points lying on a plane that are located at a fixed distance called a radius. And they form from a given point called the center. So the radius is simply the distance from the center point to a point on the circle. Now a diameter of a circle is a line segment that passes through the center with both endpoints lying on the circle, and the circumference is the distance around the circle. So an angle has its vertex, and the center of a circle is called the central angle. So here angle BCA or ACB is the central angle. So the relationship here between the measure of the central angle and an arc is formed by this proportion. So the measure of angle ACB divided by 360 degrees is equal to the length of arc AB, the red line, divided by the circumference of the circle. So we're going to use this relationship to solve this problem. Now a circle has a circumference of 12 meters. If a central angle ACB has a measure of 120 degrees, then what is the length of the arc from A to B? So we're going to go ahead and use the proportion that we were introduced to earlier. So the length of arc AB divided by the circumference of the circle, which happens to be 12 meters, is equal to the measure of the angle ACB, which happens to be 120 degrees, divided by 360 degrees. We're going to use this proportion. We can cross multiply, and we end up with a measure of arc AB, which is 4 meters. Now the last example is that we can actually use elementary geometry to estimate the circumference of the Earth. Now again, this is just an example, right? So now assume that lines L and M are parallel and they're cut by the transversal T, and you can go ahead and see this in the diagram given. Now point C is the center of the circle, therefore angles alpha and beta are equal to each other. So to measure the circumference of the Earth, we just place a vertical pole on the ground and wait until noon when the rays of the sun and the pole form an angle of 0 degrees. Now suppose that at the very moment a friend is 1,000 miles away, also has a similar vertical pole, and the sun's rays make an angle of 15 degrees with the pole that he is holding. Now we can use the proportion from earlier to actually solve for the circumference of the Earth. So the measure of angle beta divided by 360 degrees is equal to the length of the arc cut by the sides of beta divided by the total circumference of the circle. And in this case, is 15 degrees divided by 360 degrees is equal to 1,000 divided by C. And then we cross multiply and we solve for C, and we get 24,000 miles. And that's the end of section 9.1. Thank you.